Good morning. Welcome to my fifth lecture on Fourier series and Fourier transform. In this video, we are going to discuss symmetry property of Fourier series. Now, let us start with basic concepts of Fourier series that we have learned from our previous lectures. First, the sinusoidal signals, the sine wave and cos wave, they are considered as single frequency signals. That is important. Single frequency signals. Then, using Fourier series concept, we can express the other periodic signals as linear combination of sinusoidals with their harmonic components. So, if we have suppose xt is a periodic signal with time period, this is fundamental time period T naught. So if T naught is the time period, then we know that the frequency, fundamental frequency, that is the angular frequency, omega naught is 2 pi upon T naught, that is radian in second. Okay. So using Fourier concept, we can express this xt as the DC component A0 and AC components, those are sinusoidals, AN cos n omega naught t plus Bn sin n omega naught t. And n will consider all integers starting from 1 to infinity. So this is our trigonometric form, and we can find these coefficients. These are, first one is DC. DC is the average value of this signal in every period. Okay, so it is 1 upon T naught, that is the one time period, and total area under the signal within that time period. So over that one time period. So this is your average value. Next one, AN, that is computed as 2 upon T naught. First you have to multiply this with cosine n omega naught t and then integrate it over one time period. And Bn 2 upon T naught xt sine n omega naught t and dt integrate over time period T naught. So this is your trigonometric form. Whereas in exponential form, we can write xt as the summation of Cn times e to the power j n omega naught t and here n both sides minus infinity to plus infinity, all integers. Okay. Now Cn we can compute as 1 upon T naught. Then you have to first multiply xn with e to the power minus jn omega naught t. Then you have to integrate over time period. So this thing we have discussed in our previous lectures. Again, we can have some relation between these two. Okay, so what are the relations? So relations are simple. So if we consider n equal to 0 here, C0, so C0 is same as A0. Okay, because e to the power 0 is 1. So you will get same A0. And this Cn, now this exponential that you can rewrite as e to the power j n omega naught t plus e to the power minus j n omega naught t by 2. Like that here, e to the power j theta, e to the power minus j theta by 2j minus sign. So if you can combine, you see one term will come from an, other will be that j term will be coming bn upon j, and then half. So basically it is half, one term is an, and from sign it is coming bn upon j. Okay, right. Now we will consider the symmetry property on the signals. Then we will see that we can simplify our calculation. We can find these coefficients A0, AN, BN, or C0, whatever it is. We can find it easily if we can use proper symmetry function. Okay, so let us start with that one. So symmetry property. Okay, so first one we'll consider, that is odd symmetry. Okay, means the signal is, if the signal is odd, and the odd signal is defined as this one. If I consider x of minus t, if this is minus of x of t, then it is an odd signal. Okay, so if this is the odd signal, then what are the coefficients a0, an, bn, or cn? Okay, now if it is an odd signal, then you see a0. What is a0? a0 is 1 upon t0. Now you have to integrate the signal xt over one time period t naught. Okay, that time period, suppose I am considering minus t naught upon 2 to plus t naught upon 2. So if we do that one, so now this integral we can consider in two parts. One is from minus t0 upon 2 to 0, right? Another one we'll consider from 0 to t0 upon 2. So here the xt and dt, it is also xt and dt. Okay, now the first we replace t equal to, so here replace t equals to minus tau, the first only. Okay, so therefore this a0 is 1 upon t0. Okay, and then first integral, this is x of minus tau, and this one is minus d tau, dt is minus d tau, and you see this is when t equal to minus t naught by 2, then tau is plus t naught by 2, and this 0 will remain 0. It's okay. Now second term, we'll keep it as it is. So this one now, it is 1 upon t0. Now I can replace this thing, that x of minus tau equals to minus of x of tau. So this is minus of x of tau, and this is your times minus of d tau. Okay, and now I can interchange this limit. Okay, if I put interchange, then I put a minus sign here. Okay, I'll interchange, 0 will come here and t naught by 2 will come here. It's okay, and this one is remaining same. So this is your 0 to t upon 2, t naught upon 2, xt dt. So you see, so this is minus 1 minus 1 3 times, so it is negative. And it is 0 to t naught upon 2, it is x of tau d tau, and this one is 0 to t naught upon 2 xt dt. So here t is the dummy variable, here tau is the dummy variable, but the same integration. One is positive, one is negative. So obviously they will cancel. So this will become 0. So if it is an odd symmetry, a naught is 0, right? And next we'll try to find an and vn. So let us see what is our an. Okay, so an, we know that it is 2 upon t naught. There is similar logic for a one time period, and then you multiply x of t with cos n omega naught t, and then you have to integrate. Okay, again we will have two parts, 2 upon t naught. One I will consider from minus t naught upon 2 to 0 in the same way, and other is 0 to t naught upon 2. Okay, so here it is x of, so directly I can put, right, in the first one I will replace t by minus tau, then it will be x of minus tau. This is cos of n omega naught minus tau, and cos of minus theta is cos theta. So it will remain cos of n omega naught tau. Remember, so cos of minus theta is same as cos theta. That's how we write this thing. And this is dt is minus d tau. And second one, I'll keep as it is. xt cos n omega naught t dt. So again same logic. So you will see that this x of minus tau is replaced by, so this one as this one I can replace by this minus x of tau. So minus sign will be here 1, again 1 minus sign for interchange, so 0 to t naught, so 3 minus signs. Okay, I can put one more line, 2 upon t naught. So this is 1 minus sign. I'll consider to interchange the limit 0 to t naught upon 2. Okay, so tau, this will become positive. Yeah, no, right. And this is your minus of x of tau, then cos n omega naught tau, and this is minus d tau. Okay, this is remaining same. Now this is 3 minus sign, so total is minus, exactly same as earlier, minus 0 to t naught upon 2 x of tau cos of n omega naught tau d tau, and this is very simple. Okay, so these two, they are cancelling, so we'll get 0. So n is also 0. Now what about bn? Right? So bn, you see, it is 2 upon t naught, that you have to multiply with xt sine n omega naught t, then you have to integrate. So here's for one time period. The only change is that earlier it was cosine, no? As it was cosine, so okay, let me write. So this limit I can consider from minus t naught by 2, so t naught by 2. Then this one again will have two parts. One is minus t naught upon 2 to 0, other one is 0 to t naught upon 2, and here it is xt sine n omega naught t and dt, and this is again x of t n omega naught t and dt. Okay, now in the first one here, as we did earlier, we'll put or replace t by minus tau. So in this case, what you will get, so it is 2 upon t naught. In first limit is changing, minus 2 plus, it's t naught by 2, and this is 0, and this is your x of minus tau, and this is sine of n omega naught t minus tau. Sine of minus theta is minus sine. This is the difference. You see, it is minus sine n omega naught tau. Earlier cos was even function. That's why cos of minus theta is cos theta. Now here sine of minus theta is minus sine theta. And it is minus d tau. Okay. And the rest one is same. Okay. So Now if you interchange the limit, now here you are getting this one 2 upon t naught. So first I will interchange the limit with the minus multiplication. So it is 0, it is t naught by 2. Then we replace this one as minus of x of tau, right? Then this one is again minus sign, this minus minus plus. Okay, right now I'm considering sine n omega naught tau, and it is d tau. This is again 0 to t naught upon 2 x of t sine n omega naught t dt. Now again this minus minus plus. So this is plus, this is plus. So both are same. No sign change. So here it's become double of this one. Okay, they're not cancelling. So it is double of this one. So I can consider 4 times and upon t0 and then this one. Only 1, 0 to t naught upon 2 x of t sine of n omega naught t dt. So this bn may not be 0. Okay, we are not sure about this bn, but this bn simplifies to this thing only. Only 1/2 is sufficient. 0 to t by 2, you will integrate this one and then multiply with 4 upon t naught. You will get bn. Okay, so bn could be non-zero. So what is the conclusion? Conclusion for odd signal, what we are getting? We get that an is sure to be 0, a0 is 0. So an means n equal to 1 to n equal to 1, 2, all those things. Okay, those are zeros. But bn in general it is not 0. Okay, but some bn could be again 0, right? But we are sure about these two, a0 and an all are zeros, right? And bn we can calculate simply taking 4 upon t naught, just one side half time period, 0 to t naught upon 2, then multiply x of t with sine n omega naught t dt. That's all. So this is about trigonometry function. So what about Cn? Okay, so Cn, now I'll consider that it's odd signal and real. So everywhere we'll consider real signals, means the a0, an, bn all are real components, right? So if they're real and odd, then Cn, you know that Cn is half times an plus bn upon j. Now an is 0, so it is bn upon 2j only. It's okay, no others. So it's a imaginary. This is only imaginary. Purely imaginary, Cn. Okay. Now we can take few examples where you will get these things. You see one example. So one is this square wave that we have considered earlier. Okay, this side as well. Right? So this is your time period. This is your 0. This is your t naught. This is your t naught by 2. Right? This side is minus t naught upon 2, right? And magnitude is 1 and it is suppose minus 1. So this is your xt signal, suppose x1t. And you see this is clearly, it is a odd signal because 0 to t naught by 2 it is 1, whereas left side 0 to minus 2 it is minus 1. It is opposite. Okay, so it is odd signal, and for this odd signal we can easily compare. We know that it should be the a0 is 0 because average is obviously 0, positive 1 and negative 1. Okay, and an is also 0. These two, they are going to be 0. Just we need to calculate bn, and bn easily we can calculate. It is 4 upon t naught. We'll consider this thing, and only one time period, this 0 to t naught by 2, and that time its value is 1. So this is I replace by 1, and I had multiply sine n omega naught t dt. Okay, so this simplifies, this is as 4 upon t naught, and this integration is minus cos n omega naught t upon n omega naught. So it is 0 to t naught by 2. What is the value? So this is 4 upon t naught. Now this n omega naught, okay, I can take outside, and minus n also I can take outside, minus 4. Okay, so this one, first one is cos n omega naught t naught by 2, and minus cos 0 is 1, right? Now omega naught t naught, that you know that omega naught is 2 pi upon t naught. So omega naught t naught, this product is always 2 pi. So if I replace this one, so what you will get? This is 2 pi and minus sign, now I can multiply there. So 4 upon 2 pi n, and minus sign I am considering here 1 minus, and now it is 2 pi, cancel out, so cos of n pi, and cos of n pi, you know that it will oscillate plus 1 and minus 1. Okay, so n equal to 1 it is minus 1, n equal to 0 it is 1, and n equal to 2 again it is 1. For all even it is a plus 1, all odd it is minus 1. Okay, so this is simply for this is 2 upon pi n, and this is 1 minus, this is minus 1 whole to the power n. So that we can write that. So the bn, so for odd it is becoming 4 upon pi n, for odd n, and this is 0 for even n. Okay, so thus it is done for this periodic signal. So what is your time function? The time function we can write xt, only this one. So with n equal to 1, it is 4 upon pi. First component is sine omega naught t, and second component, again next odd, 3, n equal to 3, because even time is absent. It is 4 upon 3 pi sine 3 omega naught t, 4 upon 5 pi sine 5 omega naught t, these things. Okay, and you see the bn we have got. So cn in a complex exponential form, it will be bn upon 2j. So if you do that one, it's bn upon 2j. So it is 2 upon j pi n or n pi, right? So this is, you see, it is a purely imaginary, so it's okay, right? So any example, if it is a odd signal, a0 and an all are be 0, only you need to calculate vn and you will get cn simply. Okay, so you may consider one sawtooth wave like this. So if I consider one sawtooth wave like this, this one, this is one, and again it is like this, this side like this, okay? And if it is t0 by 2, it is minus t0 by 2, you see it is clearly, it is an odd signal. This is positive going, it is a negative side going, negative value, okay? So this is odd signal. So this is a 1x2t, and we had considered this one earlier, and we are not going to calculate again. Just I want to mention that in this case as well, the bn, so a0 equal to 0 here, an is also 0, and bn for this one we got 2 upon pi n minus 1 whole to the power n plus 1. So it's alternate. bn is positive and negative alternately. Okay, thus the signal x2t will become, so first one is n equal to 1, it is 2 upon pi, the sine component sine omega naught t, and next component here is all, okay, all harmonics. So then second n equal to 2 will be there. So this is but negative sign. So 2 upon 2 pi, okay, I write 2 pi only, okay, sine of 2 omega naught t. And next one is positive, 2 upon 3 pi, sine of 3 omega naught t, and it will continue. This is the expansion, okay, and you can find the cn. So cn is half of this one, and j, so it is 1 upon j pi n, and again it is alternating, okay, right? So you can consider any others. Now we'll move to the next one. So second property, the even symmetry. So if the signal is even, then when the signal is even, if x of minus t is same as x of t. So it is just the opposite logic. Earlier one minus sign was there. That's how this a0 and an, they cancelled. So the first half and second half, minus t0 by 2 to 0 and 0 to t0 by 2, they are cancelling. But in this case they will not cancel for a0 and an. Rather bn, now it will cancel. So here we can easily say that bn for this one, bn is sure to be 0. But an and bn, an and a0, it may not be 0. Okay, so if bn is sure to be 0, then what is your Cn in exponential form? In exponential form, it is an by 2 only. So I am considering real signal. If it is real, an is also real. So this is real. So Cn is real. That is important. Whereas Bn is 0 for trigonometric function. Okay, so we need to calculate A0 and An. And A0 An you can calculate. How can you calculate A0? A0 is simply average 1 upon T0 x of t dt. And An you need to calculate, but again 2 times. So it is 4 upon T naught, only 1/2. You can consider 0 to T naught by 2. Then multiply xt with cos n omega naught t and dt. Right? So can I take one example? Fine. So the example we can take, okay, we take the next slide. Take one example. Suppose if I consider this one, I need to consider one even signal. Okay, this type of square wave. Right? This is your time t, and this is suppose your x1t. So here amplitude is 1. So amplitude is 1 and it is -1. This is your 0. And this is your t naught by 2. This is the half. And this is your -half. Right? Now can we calculate? So we know that for as it is a even signal, even symmetry, first of all, the Bn should be 0. Now what is the An? That we need to calculate. Now, what is A0 first? A0. A0 is average value 1 upon T0 x of t dt for entire time period. Now you see positive half and negative half. It is symmetrical. So total positive half, total negative half same. So total area should cancel and it will become 0. Means there is no DC component, average component, because this signal is oscillating with respect to 0 axis, both sides. That's how A0 should be 0. Just looking at the signal, you can say that whether it is 0 or non-zero. It is simply a DC value. Now what is the An? An we need to calculate. So 4 upon T naught. I'll consider only 1/2, 0 to T naught by 1. Okay. And then x1t. I should multiply with cos n omega naught t and then dt. So how to compute? So this is 4 upon T naught. Now again, for this one, I need to consider two region because 0 to T naught by 4 is 1 and T naught by 4 to T naught by 2, it is -1. So I need to consider these two. And T naught by 4 to T naught by 2. That's right. So you see here it is 1 cos n omega naught t dt, and here it is -1. This within this period, this time range, it is -1. So cos n omega naught t dt. So you see, this is 4 upon t naught. This is your minus. So integration of cos is minus sine n omega naught t upon n omega naught 0 to t naught by 4. Here it is same, but it is minus sign. That minus minus plus. So it is sine n omega naught t by n omega naught. It is t naught by 4 to t naught by 2. Okay. So this n omega naught I can take outside. Come on. 4 n omega naught t naught. Then first one is minus sign. So minus sine. Now this is n omega naught t naught by 4. Then sine 0 is 0. Minus this plus sign first. Sine of n omega naught t naught by 2. Then minus sine n omega naught t naught by 4. So you know that omega naught t naught, we know omega naught t naught equals to 2 pi. So this is a 2 pi. So this will become 2 upon 2. This 2 pi can to cancel out. So here it is n pi, 2 upon n pi. And it is 2 pi upon 4, means n pi by 2. So minus sine n pi by 2. Again it is minus sine n pi by 2, last one. So this 2 I can combine. Okay, minus 2 sine n pi by 2. And this is 0. And this one is again 0, right? Because this is your sine n pi. So one thing I have considered integration of cos, so it should be plus sign, okay? It's plus and this is minus, okay? Just only one change. So I'll put a minus sign here, okay? So integration of cosine is simply sine, not minus sign, okay? So this is 0 because sine of n pi is always 0. So this is 0. So total it is 4 upon n pi times sine n pi by 2. That is your an. So an is simply 4 upon n pi sine n pi by 2. Now this function sine of n pi by 2, you see this one, this sine function. So first pi by 2 is here, plus 1. Second pi by 2, 2 into pi by 2 is 5. Sorry, that is 0. Third one is minus 1. Then it is again fourth one is 0. So all time 1, 0, minus 1, 0, plus 1. Okay. So for all even it is 0, and all for odds alternatively plus 1 and minus 1. Okay. So it will contain only odd harmonics, but sign will alternate. Okay. It means that if I consider the signal x1t, the first component n equal to 1, its value is 4 upon pi. Okay. So that coefficient, this is cos omega naught t. And next one, this is 0, n equal to it is 0, it is absent. And third component, n equal to 3, it is minus 1. So minus 4 upon 3 pi. Again it is cos 3 omega naught t. Then next one, fourth is absent, and fifth is plus sign 4 upon 5 pi sine 5 omega naught t. 6 is absent, and 7 4 upon 7 pi, it is minus sign. And it will continue. So this is the n. So easily you can calculate Cn. I think it is very simple. So it is an by 2. That's all. Means 2 by n pi and sine n pi by 2. So it's okay. So this is one example. We can take so many examples. So last class we discussed one triangular wave. Triangular wave that we discussed in the last lecture. And you can see this one. So this type of triangular wave okay, so again this side, this height is 1, it is 0, and this time is t naught here. So this is your x1t, x2t. For this signal we got the expression. Okay, just I want to mention that one. What is this one, x2t? So as it is a even function, it will have only cosine, no sine. And the logic is very simple. Total Fourier series is a combination of sine and cosine. And sine is odd function and cosine is even function. So if overall function is even, then it cannot contain the odd function, the sine terms. Only it can contain cosine terms. Okay, and DC also. So in this case, DC will be there because all time it is positive, some DC value. And that DC value is, in this case, if you compute, it will be half. Okay, and AC components are cosines. So this is like this, 4 upon pi square, and this summation, all cosine, but again the odd harmonics only. The cosine of 2n minus 1 I am considering to make it odd, omega naught t upon 2n minus 1, that square, and n equal to 1 to infinity. Okay, fine. Now next concept, next property that is important one, the third one, that is called half wave odd symmetry. So what is this? So it says the half wave. So if we shift the signal by half length, half of wavelength, half of time period, then if it looks like a odd, means x of t and t is shifted right side, suppose by half of t naught by 2, then if it becomes negative of x of t, okay, amplitude becomes negative, then it is called half wave odd symmetry. This is the definition. Okay, now I can take one example of that one. It's okay, I'll take that example later. So What about this A0, AN, BN, all those things? We need to calculate. Now, first comment I'll make, that is, for this one, A0 should be 0. Okay. And AN and BN, they may be 0, may not be 0, but we are not sure about that. But one thing it is sure, that this AN for even components, it is 0. Okay. But for odd, it may not be 0. Okay. For even, it is 0, sure. So even does not exist. A2, A4, B2, V4, all those things. Only odd components will exist. So in N, Bn, the odd components, odd harmonics will exist. Okay, and even harmonics are absent. Okay, let us prove that one. Now, this is a statement for half-wave order symmetry, that always we will consider get A0 equal to 0, and Bn and Cn, those coefficients we can calculate, it could be non-zero, but only odd harmonic it could be non-zero, but even harmonics are absent, they are 0. Okay, now what is A0? So A0 is 1 upon T0, simply x of t, okay, and dt. Fine. So one time period I will consider 0 to t naught. That is okay. That we can do. Now this thing we can consider in two regions, 0 to t naught by 2 and this is t naught by 2 to t naught. This is your xt dt, again x of t dt. Now here I replace for the first, okay, let us consider separately. That we will consider as I1 plus I2. Okay, so here I1 is 1 upon T naught, this 0 to T naught by 2, x of t dt. Now replace here, replace t plus T naught by 2 equals to tau. Okay, in this integral I1. So from here, what I will get? So I1 is simply 1 upon T naught. Now t is tau minus T naught by 2. Okay, and dt equals to tau, and the limit when t equal to 0 it is T naught by 2, and when t equals to T naught by 2 then it is T naught. Okay, it's very simple. Now x of tau minus T naught by 2, x of tau minus T naught by 2 is written as minus of x of tau. So can I write this is minus of x of tau, so it is minus outside 1 upon T naught, it is T naught by 2 and T naught, this is your x tau and d tau, right? So this I1 and this I2, you see this is t naught by 2 to t naught xt dt, that area. It's same as this tau is dummy variable, but it's minus sign. So I can say that it is same as I2 but with negative sign. So I1 plus I2 will become 0. They'll cancel. So A2 is becoming 0 because I1 and I2, they are same magnitude but with opposite sign. They are cancelling. So it is true every time. Okay. So DC cannot exist. Now what about the AN and BN? Again, similar logic we will do. Okay. So let us see. What is your AN? 2 upon T naught, and integration for one time period. I'll consider 0 to T naught, or again, okay, minus T naught by 2, that also I can do. So anything to T naught by 2. It's okay. So one time period, any one time period I can consider. It is x of t multiply with cos of n omega naught t and then integrate. Right? So again we'll have these two part, 2 by t naught and then 2, I break it, one is minus t naught by 2 to 0 and 0 to t naught by 2. This is your x of t cos of n omega naught t dt, same as x of t cos n omega naught t dt. So I'll consider these two as I1 and I2 again. Okay. In similar way, I can find I1. So I1 is this one, 2 upon T naught is minus T naught by 2 to 0. It is x of t cosine n omega naught t dt. Now for this case, put again in the same form, t plus t naught by 2 equals to tau. Okay, if I put. Now, so you put this one, what will get? 2 upon t naught. This integral. Now this x, t is replaced by tau minus t naught by 2. Okay, this cosine n omega naught tau minus t naught by 2, and dt and d tau same. So dt is replaced by d tau. Now limit, when t equals to minus t naught by 2, then it is becoming 0. And when it is 0, it is becoming t naught by 2. Right? Now what I'll do, it is 2 upon t naught, this integration 0 to t naught by 2. Now this x of tau minus t naught by 2, by definition of half-wave odd symmetry, it is becoming minus x of tau. Okay, and this one we can break. It is a cosine n omega naught tau minus n omega naught t naught by 2, and omega naught t naught is 2 pi, 2 to cancel out, so n pi. So this is simple n pi. I write n pi. You understand that omega naught t naught by 2, that is equal to pi, and it is d tau. So this one we can break. 2 by t naught. So something minus sign is there. Outside I will take x of tau, and this one cos of n omega naught tau, cos a minus b, cos a cos b, cos n pi plus sin a sin b, sin n omega naught t, and sin of n pi. Then d tau. Oh, sorry, it was tau. Okay. Now you see, sin of n pi is always 0. That is always 0. And cos of n pi, and that I said that it will alternate. No? N equal to 1, it is minus 1, n equal to 2, it is 1, then again minus 1, 1, like that, minus 1 whole to power n. So this one I can replace by, that is equals to minus 1 to the power n. Okay, so what you will get? So this is minus 1 whole to power n, and so this is 2 upon, can I write it is minus 1 whole to power n plus 1, 2 multiplied by 2 upon t naught, and this is your x tau cos n omega naught tau and d tau, and that is same as, so okay, this thing I will put it here again, x of tau cos of n omega naught tau d tau, 0 to, so again limit is 0 to t naught by 2, here also t naught by 2, and I2 the same limit, so it is same, 2 upon t naught, this part is same, it is the I2. So can I write, it is minus 1 to the power n plus 1 times I2. So for even, when n is even, then this is becoming odd, means minus 1. In that case, I1 plus I2 will become 0. So thus this an equals to 0 for even n, and it is equals to simply 2 times of I2, and that is same as 2 times means I2 is that one, no, 2 is 4, 4 upon t naught, and integration 0 to t naught by 2, this xn xt cos n omega naught t dt, and that is for odd n. So for all even n, an is absent. The even harmonics are absent, but even odd harmonics can present. Okay, we are not sure about this thing, that whether it is 0 or not, but in general it may not be 0. Right. The similar way, we can say that, exactly similar way. So if you force it, then you will get that Bn is again 0 for even n, and this is equals to 4 upon t naught integration 0 to t naught by 2 xt sine n omega naught t dt. This value you will get for odd n. Right? So one conclusion is that even harmonics are absent and odd harmonics can be there. Now sine and cosine both could be there, one could be there. Okay, so that depends on other properties. Right. Now let us take one example. So that example we had already taken. Okay. Suppose if I consider this kind of square wave, this is your x1t, this is your t naught by 2, this is your t naught, this is minus t naught by 2, minus t naught. Okay, fine. And amplitude is 1 and minus 1. And you see, if you shift right side or left side by half time period, you will get the opposite only. So this positive will come here, and that time it is negative. So it is simply odd. That's how it is called half-wave odd symmetry. Now, as it is a half-wave odd symmetry, we understand that A0 should be 0. That is true as well. We got. And AN, BN, now it can have only odd harmonics. Fine. But not only this signal is as well a odd signal. X1t, this is odd signal. And as it is an odd signal, it will contain only cosine signals. No cosine terms will be there. So all cosine terms will be there. So an is also 0. Only bn will be there, but bn will contain only odd harmonics, right? And that already we have calculated. That value is 4 upon pi n for odd n, and it is 0 for even n. You see, this is beautiful thing. Okay, we can, so how to do, we'll calculate only bn, and bn will be this one, 4 by t0 to these things. So that is very easy to calculate 4 upon pi n, that you will get. Okay, now let us consider, give you some more example, and be careful about using this half-wave odd symmetry. So next example, if I consider this kind of triangular wave, okay, consider triangular wave. Like this. So this is your time t, and now if I consider this is your t naught, and this is your t naught by 2 minus t naught by 2, this is your minus t naught. Okay, it is 0. This height is 1 and it is minus 1. So if you shift this one to right side, so here you will get this one. Okay, if you shift by t naught by 2, you will see that this peak is coming here, that is positive, but this time it is negative. So it is a half-wave odd symmetry. Okay, so it shows half-wave odd symmetry, and we can use the property here. Again, not only this is also this x2 signal. So x2t, it will show first of all half-wave odd symmetry. Okay, and this also, it is an odd signal, right? This is also an odd signal. Means again this x2 signal will have only the sine components and odd harmonics. Okay, so you can calculate those values, sine component and odd values. So it's possible to calculate. So what you'll do, you can take derivative. So in the last lectures, the differentiation property we have introduced, no? So if I take derivative of this one, what you will get? So can I take derivative of this one? So this is positive slope. Then this one, this is your t naught by 4 minus t naught by 4. This is your t naught. Okay, so within this one, I'll have positive slope. And then from here to here, from here to here, this is a negative slope. Like this. Again, you will get this side. This is a negative slope. So you will get this kind of square wave. This is your derivative of x2 signal. Okay. And for this one, we can find easily if it is your t naught. So which one is t naught? This is your t naught by 4. This is your t naught by 2. Okay. This is a minus t naught by 4. And this is your minus t naught by 2. Right. So already we have computed, no, for the this is the event signal, and for the event signal, what is your Cn? The Cn we have considered. So for this one, Cn prime I'll write is how much? It was, this one is 2 upon n pi, and we got sine n pi by 2. Okay, so if it is the Cn, the corresponding Cn prime, this Cn prime, this is for this one. So for this x2 signal, what is the Cn? Cn will be Cn prime upon j n omega naught. Is it right? So if you combine these two, what you will get? And probably here one thing, this amplitude, this is for with amplitude 1 here. Okay, but here amplitude is not 1. How much amplitude you will get? So what is slope? Slope is within this one t naught by 4, it is becoming 1. Sorry, yeah, this is t naught by 4, and that is becoming 1. So it's 4 by t naught. The slope is 4 by t naught. I think it is correct, because this duration is half t naught. The time changes is 2. So 2 by t naught by 2 is 4 by t naught. It's correct. So that you need to multiply 4 by t naught here. So 4 by t naught should be multiplied. Okay, so whatever you will get, so it is 8 by, so in this case it is 8 upon j n square pi omega naught t naught sine n pi by 2. Okay, and omega naught t naught again 2 pi, 2 to cancel out, so it is 8, that is becoming 4, it is j n square pi square and sine of n pi by 2. As the Cn is purely imaginary, so original signal will have only sine terms. It's odd signal, okay? So that is very easy to. So now you can combine. So what is the values, all those things. So it's alternate. Sine is alternate and it will become double of that. Probably x to t could be like that. So first one will be the 8 by pi square, that we will check, and this is at 1, it is 1, okay, and it is the sine omega naught t, and next component is minus sine, and then n is 3, because only odd component, this is for only for odd, okay, only for odd n, this is for odd n, remember, right? So next will be 8 upon 3 square 9 pi square times sine of 3 omega naught t, and then continue like that, okay. Now you have to be a little bit careful while you will use this half wave odd symmetry. Now if I consider this signal, this kind of sawtooth signal, okay, this was x3t. Now this signal, is it an odd half wave symmetry? This is an odd signal, by the way. It is fine, it's an odd signal, but it is, this one x3t, this is an odd signal, but does not show halfway odd symmetry, because if you shift this one, then it will become like this. It will become, because this is vertical, no, this is perfectly vertical, and here it is this one. It is not exactly opposite of this one, okay. So it is not halfway odd symmetry. It is not correct. So you cannot use the halfway odd symmetry concept here, and thus you see that it will contain all the harmonics, okay, not only odd harmonics that we have seen already, okay. So you have to be a little bit careful. Now just last one, the fourth property we will consider, that is called half wave even symmetry. Now this half wave even symmetry, the concept, okay, what I can say, so if I shift the signal by half wave, okay, then if I get the same xt, then it is called half wave even symmetry. Now you may be surprised about this one. Now in periodicity we have said that if xt is a signal, and if after t naught time period is t naught, then it will repeat itself. So it is similar to that. So it is showing that instead of t naught by 2, it will repeat. So basically, this is a periodic signal with time period t naught by 2. So half of that. Okay. But this concept is sometimes useful. So you may consider in that way that this signal basically its time period is t naught by 2. So frequency is double. Okay, with respect to the t naught. Now, but if I consider in that way, then what we can conclude? We can conclude that this A and Bn, they will contain even harmonics only. No odd harmonics will be there. Okay, all odd harmonics are absent. Okay, that we can prove in a similar way what we have done last time. Okay, so as it is not a negative sign, it's plus sign, so that's how you will see that A and Bn, when it is even, then only it will not cancel, otherwise for all odd it will cancel. Okay, it will become 0. So just see the application. I'll consider one application for this half-wave event symmetry. Suppose I want to calculate the Fourier series for half-wave rectifier. Signal, okay, we call rectified signal. Means you know that what is half-wave? Only one half is rectified, is made 0. If this is the time, now the sine wave, original signal is sine wave, so it is sine wave. But this half is 0, is made 0. Again, next half will remain there, and then 0, like that. So this is 0. From here to here, you will have a sine wave, and again it is 0, like that. Okay, so this is your 0, this is your t naught, this is a t naught by 2, and this signal is suppose x1t. Okay, so this is the half wave signal, or rather I can write in name x half wave, and it is t. And now how to compute this one? Now if I look at two different signals, one is, I'll consider these two. One is pure sine wave, okay, this is your sine of omega naught t, okay, and next one, if I consider a full wave rectifier, this one and negative is becoming again positive. It's full, both the waves are rectified. Earlier the half wave positive waves is remain there and negative half is truncated. Okay. Fine. And that I'll call it x full t. So this is your, so with respect to this time period t naught, and this is your t naught by 2. If I use the same convention, this is your t naught and this is your t naught by 2. Then this is your time period, original signal time period. Okay, I'll continue with that same time period. Otherwise, you'll see that this full wave rectifier will have a repetition after t naught by 2 only. So this is basically time period for full wave rectifier, but we'll still consider t naught as a time period, right? Now these two, if we combine, just add, so negative and positive, this will cancel and I'll get 0. And these two positive, now it will become 2 times. Okay, so to get this green one, this half wave, can I write this x half wave rectifier? It is the combination of sine omega naught t plus this x full but that time it will become double, so I'll put half here. Okay, so this is basically half sine omega naught t plus half x the full wave. So using the property, linearity property of Fourier series, now we can find the Fourier series coefficient for this x half. If I know that, the Fourier series coefficient for x full, because this is simple sine omega naught t, pure sine wave, single frequency. Okay, now we need to consider this full wave rectifier. What is the Fourier series coefficients? Okay, now how to calculate the Fourier series? So we'll continue a few more times. Now this is now our task. We'll consider this full wave rectifier. It's okay. This is 0. We'll still consider here it is t naught, remember, and this is your t naught by 2, and this is your minus t naught by 2, and this is your minus t naught. Okay, and you see, if I shift it by half, I'll get the same thing. So half wave symmetry, half wave even symmetry is there. Okay, so you understand that it will contain only even terms, harmonics, no odd harmonics. Okay, so maximum height is 1, still 1, I am assuming. Okay, so this is your x full t. So for this signal, what is the A0 first? Can I calculate A0? That is the average value. So I can consider one time period. So it is repeated. So I may consider half of time period. That is fine. Okay. So what is the average of this one? 0 to t by 2. So this time is t0 by 2. Within that, I'll consider, so 0 to t naught by 2. This signal I'll integrate. This is a sine omega naught t dt. Okay, so it is 2 upon t naught 2 is coming here, and integration of this one is minus cos omega naught t upon omega naught 0 to t naught by 2. Now if you simplify it, what you will get? It is 2 upon t naught, and this omega naught outside, omega naught t naught, and minus also I can put outside. Okay, I'll keep it within that one. So minus cos omega naught t naught by 2 minus plus 1. Okay, and you know that omega naught t naught is 2 pi. So it is 2 upon 2 pi, and this is your minus cos 2 pi by 2, and this is plus 1. So 2 will cancel here, and 2 will cancel here. So cos of pi is minus 1. So minus 1 plus 2. So it is becoming 2 upon pi. So this value is 2 upon pi. So it could be around here. This is a little bit upper side. Okay. This is the average value. 2 upon, so this gap is 2 upon pi. Point more than 0.6. This is 1. Okay. So little bit higher than 0.5, middle. Now, what is about AN and BN? Now, as it is a even symmetry, again, it is a even symmetry. Not only half-wave even symmetry, it is also even symmetry. Remember. So, as it is showing even symmetry, so BN will be 0. That is sure. So, A0 I have got 2 by pi, BN is 0. Only I need to calculate AN. Okay. So, what is AN? And you know that AN we can calculate considering half of the time period. That's all. So, this, you know that AN, now we can calculate 2 times. So 2 times of 2 by t naught means it is 4 by t naught, and only I will consider this half t naught by 2, is right. And this signal this time is sine omega naught t multiplied with sine n omega, sorry, this is the cos. This cos n omega naught t and dt. That we have to integrate. Okay. So this one we can write as, so an, now again I will consider 2 by t naught, and 2 I will put inside, 2 into sine omega naught t and sine n omega naught t, sorry, again mistake, it's a cos, remember this is your cos signal. Okay, dt 0 to t naught by 2. So sine a cos b, so 2 by t naught. So this thing we can consider in sine of a plus b, means sine of n plus 1 omega naught t minus sine of n minus 1 omega naught t. Okay, this is 0 to t naught by 2. So if I integrate it, then it will become 2 by t naught, and this value sine, it is a minus cos n plus 1 omega naught t upon n plus 1 omega naught. And this is again minus plus. This is cos n minus 1 omega naught t upon n minus 1 omega naught. Now here it is n minus 1 divided. So n equal to 1, it's becoming infinite. But already I've said that this signal will have only even harmonics. So n equal to 1, it is already 0. We will not consider. So here n, we are considering all evens, even numbers. So it is ruled out. N is 1 is not there. So I started 2, 2, 4, all those things. So we can divide by n minus 1. No harm. So limit is 0 to 0 by 2. Now, if I put this to limit, then what you will get? So if I consider t equal to t naught by 2, I will get, so okay, this omega naught I will take outside. Now, so this will be only cos n plus 1 omega naught t naught by 2 upon n plus 1. And if I put minus sign here, okay, so this 0 minus 1 is plus, and cos 0 is 1. So this is 1 upon n plus 1. And for this one, it is cos n minus 1 omega naught t naught by 2 by n minus 1. And for 0, it is minus sign 1 upon n minus 1. Now this is omega naught t naught equal to 2 pi. So it is pi. And cos of n pi plus pi is only cos n pi minus cos n pi. Okay. So this we can replace by pi. Okay. And again, cos of n pi plus pi is same as minus cos of pi plus theta is minus cos theta. So cos of n pi. And again, cos of n pi, we can, okay, first we'll put it that one, this way. So it is basically, it is becoming cos of minus cos of n pi. So minus and plus. So 1 plus cos of n pi. So see, so this is equal to pi. So it is becoming, this also we are considering as a pi. We'll consider as a pi, 1 upon pi. Okay, so this is 1 upon pi. So this one total minus cos n plus 1 times pi is becoming minus cos n pi. So minus and plus. So cos n pi, and this is n plus 1 plus 1. So n plus 1 is this one, and this one is here. Okay, and again, this is your minus cos n pi. Similarly, for second one, this cos of n pi minus pi. This is cos of n minus 1 times pi. Cos of n pi minus pi. It is again same as minus cos n pi. Okay. So what you can write? This is minus sign. Again, cos of n pi plus 1 upon n minus 1. So 1 plus cos n pi, that is common. Okay. So we'll continue. So therefore, an, I can write 1 by pi and cos of n pi plus 1, and this is 1 upon n plus 1 minus 1 upon n minus 1. Okay, so now it is 1 upon pi And this one, if you simplify it, this is your minus 1 whole to the power n cos n pi, and this is your n square minus 1, and this is your n minus 1 minus n minus 1. So this n will cancel out. It is minus 2. So it is becoming minus 2 times minus 1 to the power n plus 1 upon pi times n square minus 1. Now you see, when n is even, then only it is 1. 1 plus 1 is 2. So therefore a n, for even it is 2, 2 is 4. So minus 4 upon pi times n square minus 1, that is for even n. And for odd n, it is 0. Right? So this is all. So this is all for an. Now if I get the an, a0 I have got it. So a0 is 2 upon pi. So now I can write the signal x full wave t. The signal is simply, so first one is DC value 2 upon pi, and then this combination. Okay, so minus 4 upon pi, and this is varying, so it is summation all cos signals, but only even we would consider the cos of n omega naught t upon n square minus 1, and n is even, only even 2, 4, all those things. So this is your full wave rectifier expansion Fourier series. And if it is full wave rectifiers, now you can see what is your half wave rectifier. So therefore x half wave, that you know that it is half of the half of sine wave sine omega naught t plus half x of full wave. Okay, now x of full wave we have got this one. So if I replace, so DC will be 2 upon pi, 2 to cancel out, 1 upon pi. So that I will take first. Then this sine component, half sine omega naught t, and then all negatives, cosines, 4 upon pi. So 4, 2 divide. So 2 upon pi. And summation, this is cosine n omega naught t upon n square minus 1, but all even n. That's all. So this is the expansion for half wave rectifier. So you see the use of the half wave even symmetry. Okay. So in the next class, next video, we'll be discussing the Parseval's relations, and then we'll conclude. We will give you the summary of this Fourier series. Thank you.